China's lunar probe has landed, carrying samples from an unexplored far side of the moon.
The Chinese lunar probe has successfully taken off from the far side of the moon to start its journey back to Earth.
Classified reports from China's moon mission just leaked, and what they contain is genuinely disturbing. Not disturbing in the way headlines usually mean. No mysterious structures, no alien signals, something far harder to explain away. When China's Chang'e 6 probe returned from the far side of the moon in June 2024, the first mission in history to bring material back from the hemisphere that permanently faces away from Earth, the findings were quietly processed inside a secured Beijing laboratory.
China has long been shooting for the moon, and these tiny lunar rocks it brought back are one of the reasons why.
And what scientists observed inside those sample trays directly contradicted what the official mission summary told the world. The soil moved wrong. It behaved in ways no lunar material had ever behaved before. And the deeper the analysis went, the more the data pointed toward a single conclusion that planetary science had never seriously considered. The moon, we think we know, is only half the story. The other half has been hiding something extraordinary for billions of years, until right now. The side no one could touch you already know one side of the moon. Every time you look up, you're seeing the same craters, the same ancient plains, the same scarring that's been locked toward Earth for billions of years. But the far side, the half that permanently faces away from us, that's a completely different world. And for most of the space age, we had no way to reach it. Here's the catch. It wasn't a propulsion problem. Rockets could get there. The problem was something far more basic and far more absolute.
In 2025, China set a new national record for orbital launches in a single year.
Radio signals travel in straight lines. They don't bend around mountains. They don't pass through solid rock. The moon is an enormous sphere of stone and compressed metal, roughly 2,160 miles in diameter. The moment a spacecraft drops behind it, Earth disappears from the signal instantly. There is no pathway. The signal strikes the lunar surface and dies. Engineers call this a radio shadow. On the near side, everything works the way you'd expect. Commands go up, data comes back, and if something goes wrong, someone on the ground can catch it in real time. But cross the lunar horizon to the far side, and the connection ends completely. No telemetry, no video, no ability to send a correction. A lander descending there is alone, running on instructions written and uploaded hours before. If it starts veering toward a boulder field at the last second, no one on Earth knows. No one can do anything. That's not a technical inconvenience. That's mission death with no explanation.
Well, first of all, let me congratulate the Chinese. They are following the United States step by step.
For decades, every major space agency ran the same calculation and got the same answer. The far side wasn't worth the risk. A single slope steeper than the maps predicted, a single software anomaly in the final approach, and you lose everything. Hardware, data, years of work, with zero information about what went wrong. Almost every agency walked away. China didn't. Mapping the hidden half. Before China could land anything on the far side, it needed to understand what was actually over there. And we're not talking about basic photographs. Those existed from the Apollo era. What China needed was engineering-grade terrain data, the kind of detail that tells you whether a lander's legs will hit flat rock or a hidden boulder at 200 miles per hour. That work started with Chang'e 1 and Chang'e 2. These weren't exploration missions in the traditional sense. They were surveyors. They traced repeated, precisely calculated orbits above the far side, scanning with radar altimeters, terrain cameras, and mapping instruments that layered pass after pass into something usable. Crater depths measured to the meter, slope angles calculated to fractions of a degree. What had been a blank hemisphere slowly developed an actual topographic identity. And get this, scientists and engineers were studying the same data for completely different reasons. The scientists wanted to understand the moon's geological history. The engineers wanted to know exactly one thing: where can we put a lander without killing it? But even once a landing site was identified, there was still a problem that no amount of mapping could solve. How do you talk to a spacecraft that's permanently behind the moon? China's answer was to stop trying to go through it and instead go around it. They launched the Kuiqiao relay satellite and parked it at the second Earth-Moon Lagrange point, roughly 40,000 miles beyond the moon. a gravitational sweet spot where it could maintain a permanent line of sight to both Earth and the far side simultaneously. For the first time, there was a bridge. Commands from Earth went up to Queqiao. Queqiao sent them down to the surface. Data from the far side traveled the same path in reverse. The silence was broken, but that only meant a landing was now technically possible. Whether it could actually work was still an open question, and the answer would have to wait until someone tried. The first landing in. Iwis, January 2019, Chang'e 4 descended through the final kilometers above the far side and touched down inside Von Karman crater, a broad ancient depression deep within the South Pole Aitken Basin, one of the oldest and largest impact structures in the entire solar system. No human watched it happen in real time. There was no controller with a hand on a joystick. Chang'e 4 used preloaded terrain data and onboard sensors to guide itself through the final descent, analyzing the surface and making adjustments with Earth completely invisible behind the Moon. The spacecraft had to land itself, on a surface no mission had ever touched, with no way to call for help. It worked. Deployed from the lander was the Yutu-2 rover, 6 wheels, a spectrometer, and a mission that was almost deliberately unglamorous.
But the real narrative is that China keeps increasing its expenditures. So they're progressing towards their goal of being a leader, if not the leader in space science.
Move slowly, observe, learn what this surface is actually like, prove that sustained operations on the far side are possible. Here's where it gets strange. Early in the mission, Yutu captured an image that sent the internet into a spiral. On the horizon, there was a bright object with sharp edges that looked almost square. Chinese media called it a mysterious hut. Outside China, it became the Moon Cube. Theories multiplied fast. The rover team wasn't interested. They knew what cameras do at extreme solar angles on an airless surface. They kept moving. Over several lunar days, each one roughly 2 Earth weeks long, Yutu slowly closed the distance. And as it got closer, the object resolved into what it always was, a rock. Uneven, resting at the edge of a small crater, resembling from one angle a crouching rabbit with a smaller stone in front of it. The team called it the Jade Rabbit Rock. The internet moved on, but Yutu-2 didn't. Its spectrometers kept working, repeatedly detecting low calcium pyroxene and olivine across the landing site. When geologists compared those readings to existing models, the conclusion was significant. Some of the material beneath Yutu-2 appeared to have come from deep inside the Moon's mantle, blasted upward by ancient impacts billions of years ago and now sitting on the surface, exposed, waiting. The far side wasn't simple or uniform. It was layered, mixed, and ancient in ways that surprised even the scientists who had planned the mission. China had proven that landing on the far side was possible. It had proven that a rover could operate there for extended periods. And it had produced the first real scientific data from a hemisphere that had never been touched. But all of that was still just context for the real question, the one that had been hanging over the entire program from the beginning. Could they bring something back? If you want to find out what happened when they finally opened those sample containers, and why what they found inside quietly rewrote lunar science, make sure you're subscribed, because this is where it gets genuinely unsettling. Proving the return. Landing on the Moon is hard, leaving it is harder. The full sequence, touchdown, drill, collect, seal, launch off the surface, achieve lunar orbit, dock with a return vehicle, and survive re-entry through Earth's atmosphere, has almost no margin for error at any stage. And before China could attempt any of that on the far side, it needed to prove the whole chain worked at all. That test came in December 2020. Chang'e 5 targeted a region called Mons Rumker in the volcanic plains of Oceanus Procellarum on the near side. Communication was simpler there. Conditions were better understood. This wasn't exploration. It was a systems test conducted at the highest possible level of complexity.
No, China has a plan, and they have a track record of hitting that plan.
Every component of the return architecture had to be validated before anyone attempted it on the far side, where failure would mean no data, no recovery, and no explanation. Chang'e 5 touched down, drilled into the subsurface, and collected material with a robotic arm. In total, approximately 1.7 kilograms of lunar material sealed and transferred to an ascent vehicle mounted on the lander. That vehicle then fired its engines and launched off the moon's surface, climbed into lunar orbit, and docked autonomously with an orbiting return module. Think about what that actually means. A small robotic vehicle launched from the surface of another world, finding and locking onto a moving target in orbit with no human hand on the controls. A precision maneuver conducted without direct human intervention, 240,000 miles from Earth. The return capsule landed in Inner Mongolia, mission declared a success. But here's where it gets strange. The real news came later, in the lab. Grain by grain, scientists found chemistry that didn't belong in any known lunar catalog. Tiny colorless crystals, with no match in any mineral database on Earth. Analysis confirmed it was a new mineral entirely, named Chang'e Y, after the mission. In a region of the moon, scientists thought they understood, there was chemistry no one had ever seen. They also confirmed measurable concentrations of helium-3, implanted by the solar wind over billions of years of surface exposure. And then came something that directly contradicted one of the oldest assumptions in planetary science. Water, locked inside mineral grains in the form of a hydrated salt designated ULM1, a compound capable of trapping water molecules and ammonium within its crystal structure and remaining stable under the moon's extreme surface conditions. The moon wasn't just a dry rock. Even from the near side, the hemisphere studied by Apollo, visited by over a dozen robotic missions. It held new minerals, implanted gases, and water in forms no one had predicted. Here's the catch. This was the side we already knew, the familiar hemisphere, the one scientists thought was fully mapped. What was waiting on the other side? The impossible mission. On May 3, 2024, Chang'e 6 lifted off from the Wenchang Space Launch Center aboard a Long March 5 rocket. The mission carried 4 integrated components: a lander, an ascent vehicle, an orbiter, and a return capsule. And every single one had to work perfectly. No redundant systems, no fallback, no partial success. Chang'e 6 entered lunar orbit on May 8th and spent days refining its trajectory. On June 1st, 2024, supported by the upgraded Queqiao 2 relay satellite, the lander separated and began descending toward the Apollo Basin, a relatively flat region inside the enormous South Pole Aitken impact zone. Earth was on the other side of the moon. The spacecraft was completely on its own. Cameras, laser scanners, and hazard avoidance software analyzed the terrain in real time as altitude dropped. At 22:23 UTC, Chang'e 6 touched down. First spacecraft ever to land in the Apollo Basin. First mission to land on the far side with the explicit goal of returning material to Earth. Surface operations started immediately. A robotic scoop collected surface soil. A drill penetrated deeper layers. Total collected 1.93 kilograms of far-side lunar material sealed in a protected container. Then came the moment that mission controller Zhang Wei later described as the longest 4 minutes of his career. On June 3rd, inside the Beijing Aerospace Control Center, Zhang watched the telemetry feed from Queqiao 2 as the ascent vehicle's ignition sequence began. No spacecraft had ever launched from the far side of the moon before. The room was completely silent. Nobody spoke. Everybody watched the numbers. The ascent vehicle launched. It climbed. On June 6th, it autonomously rendezvoused and docked with the orbiting return module. A precision maneuver conducted 240,000 miles away, with no human ability to intervene. The samples were transferred in space. The orbiter fired its engines. On June 25th, 2024, the return capsule descended under parachute into Inner Mongolia. Inside, 1.93 kilograms of material from Siua, the moon's far side, the first samples ever brought back from the hemisphere that permanently faces away from Earth. The impossible mission had worked. And what came next is what nobody saw coming, what the samples revealed. The containers were transported under strict environmental controls to specialized facilities. Every step followed procedures refined through decades of lunar sample curation. Only after thorough inspection did scientists begin opening the storage chambers. That's when Dr. Li Xianhua tipped the first tray. The Chang'e 6 soil didn't flow. Near-side lunar samples, collected by Apollo by Chang'e 5, behave predictably under gravity. Fine, dry, loosely bound, they spread, they settle. The Chang'e 6 material didn't do that. The grains clumped, small clusters formed, broke apart, and slowly pulled back toward each other. Lee watched it happen and said nothing. The behavior went well beyond the electrostatic effects that sometimes appear in lunar samples. This was something else, something nobody in the room had a ready explanation for. That's not the disturbing part. That was just the beginning. Under the microscope, the visual differences became impossible to ignore. Near-side lunar soil is dark and compositionally uniform, dominated by glassy fragments and basaltic material from ancient lava flows. The Chang'e 6 samples were lighter overall, speckled with bright mineral grains that matched the moon's ancient highland crust, not the volcanic plains that should have dominated the landing site. The soil was telling a different geological story than the terrain around it, and that detail didn't make it into the official mission summary. Scientists began reading the age of the samples using crystals embedded within basalt fragments, natural clocks that record when molten rock cools and solidifies. The volcanic material from the far side cooled approximately 2.8 billion years ago. And get this, that timing matched volcanic activity recorded on the near side. Both hemispheres were geologically active at the same time, but that's where the similarities stopped cold. Researchers turned to temperature analysis. Near-side magma, as recorded by Apollo samples and Chang'e 5, averaged around 2,200 degrees Fahrenheit. The far-side basalt told a different story. Magma that had cooled from temperatures closer to 2,000 degrees Fahrenheit. 200 degrees lower. 200 degrees sounds minor. Inside a planetary body, it isn't. Hotter interiors stay geologically active longer. Cooler interiors lose heat faster, solidify earlier, shut down sooner. A 200-degree difference points to one conclusion. The far side contains fewer heat-producing radioactive elements than the near side. The two hemispheres don't just look different on the surface. They have different internal chemistries, different thermal histories, different geological identities inside the same body. And then came the water data. When scientists measured water content in the Chang'e 6 samples against near-side material, the gap was striking. The far side wasn't slightly drier, it was dramatically, measurably drier, in ways that surface exposure or impact history alone couldn't explain. The dryness came from somewhere deeper, something internal. When all of it was assembled, the clumping behavior, the mineral composition, the volcanic temperature, the water content, a conclusion emerged that the initial mission summary quietly stepped around. The moon is not internally uniform. It never was. The near side is hotter, richer in radioactive elements, more volcanically productive, and wetter in its mineralogy. The far side is cooler, chemically distinct, geologically quieter, and significantly drier. These aren't surface variations from different impact histories. They reflect two separate internal evolutions persisting for billions of years inside the same object. For 50 years, every model of the moon was built on near-side data. Every conclusion, every formation theory, every assumption about how the moon cooled, built on half the picture, the half we could reach. Why the United States is back. For decades, the moon was treated as a resolved question. Apollo answered what it could, and the scientific community moved on. The moon became background noise. Chang'e 6 ended that in a single mission. The implications don't stop at lunar science. If the near and far sides evolved along separate internal trajectories, then decades of conclusions built entirely on near-side data are incomplete by definition. Models of lunar formation have to account for a two-hemisphere body, not a uniform one. And because the moon's early history is directly connected to Earth's own, the late heavy bombardment, the formation of Earth's oceans, the conditions that eventually made life possible, those revisions don't stay on the moon. They come back here. That alone would have been enough to pull the United States back. But there's a second dimension that's harder to talk about publicly. China has demonstrated capabilities on the moon that no other country has matched. A far-side landing, autonomous ascent from the far side, sample return from a location considered inaccessible 15 years ago, a functioning deep space relay satellite network, a rover operating continuously on the hidden hemisphere for years. The capability gap is real, documented, and widening. For the US, The calculation changed the moment Chang'e 6 touched down. Artemis isn't a repeat of Apollo. It's a response to the realization that the near side alone is no longer sufficient, scientifically or strategically. The US needs its own measurements, its own samples, its own operational experience in terrain that behaves differently from anything Apollo ever encountered. Chang'e 6 showed that far-side soil compacts differently, holds different minerals, and behaves in ways that near-side data cannot predict. Any nation planning infrastructure, resource extraction, or long-duration presence on the moon needs first-hand data from both hemispheres. Right now, only one country has it. Staying away is no longer neutral, it's a concession. And get this, the findings driving that urgency are still being processed. The full scientific picture from the Chang'e 6 samples isn't complete. Papers are still being published. What we know right now is already enough to rewrite the textbooks. What comes next is still being written. What China found on the far side of the moon wasn't a structure. It wasn't a signal. It was something far more unsettling, hard, peer-reviewed, physically verified evidence that the most studied object in the night sky has been showing us the wrong face all along. Half its story has been hidden, from science, from every model built over 50 years, and from you, until now. If this is the kind of story that keeps you up at night, you're already in the right place. Subscribe, because the far side of the moon is only the beginning of what's been kept out of the picture.